How to identify classic quadratic. So the first kind of classic quadratic we're talking about is difference of squares. So it talks about how we can simplify two squares that are subtracting each other, like the word difference of squares. So here we have x squared minus y squared. According to the rule of index, we can simply combine these values and simply have x minus y all squared. This exponent is being distributed amongst the x base and y base amongst the various bases. So according to this classic quadratic, it simply says when you have two squares subtracting themselves, first you just have a bracket x minus y and then x plus y. So we're not going to go ahead through the whole process because of deriving this, because I want to keep this lesson or video concise, but this is very helpful if you can easily identify this, and it makes it fast when solving. So the next one, you have x squared minus 1. For this particular situation, I can have x squared minus 1 squared. Reason being because 1 squared is same thing as 1 multiplied by 1, which is 1. So when I say 1 squared is equal to 1, it's still correct. So nothing changes, and from this point we can now combine them, say x minus 1 all squared. So having said that, we can apply difference of square here as x minus 1 and then x plus 1. So the goal here is just to have one of the brackets adding and the other one subtracting, and then they are multiplying themselves. That's just the difference of square. Let's solve the last one. Here we have x squared minus 9, which is same thing as x squared minus 3 squared. Now we can combine them as x minus 3 all squared. So we need two brackets, one subtracting and one adding. So we can say x minus 3 and then x plus 3, and we are done. So that's just the simple rule, difference of square. Let's talk about the next kind of quadratic before we go to solve questions, and that's the conventional quadratic. So the rule says square the first term, use the exponent to multiply 2, and square the last term. So let's do that together. The first term here is x, that's the first term, and this is the last term. Then this is the exponent. So you have to square the first term, then use the exponent to multiply through, and then square the last term. So let's go ahead and solve. So for the first term here, we'll have x, so x all squared, then using 2, so we'll have a positive 2 multiplying x the first term, still multiplying y, and then finally we square the last term. What is the last term? The last term is positive y all squared. So the first term, x squared, is same as s squared, then this is 2 times x times y is plus 2xy, and then y squared, that is positive, still gives us a positive value y squared. So this is for the first one. Now for the second one, we will square the first term. The first term here is x, so x squared, then using the exponent to multiply through, so we'll have positive 2 multiplied by x, also multiplied by negative y, and then you square the last term. So the last term is negative y all squared. The first term, x squared, is s squared, s is power 2, then 2 times x is 2x, but then 2 times minus y is 2x times minus y is minus 2xy, so we have minus 2xy, and then squaring the last term gives us positive y squared. Whenever you square a negative term, it's going to give you positive. So for instance, let's say minus 1 all squared, it's talking about minus 1 all squared talks about minus 1 times minus 1. So the minus times minus is plus, and then 1 times 1 is 1. So I just wanted to clarify this. There's no need to write plus here. So this is the conventional classic quadratic. Talk about the difference of squares, and now we're talking about the conventional classic quadratic. Let's go ahead and solve questions. So let's go to the exercise. So for the first question, we have that x squared minus 2xy plus y squared all over x minus y. Now if you can look very well, you can see that the first expression, the numerator here, so remember that this is the numerator, the fraction above, and this is the denominator, the fraction below. So the numerator is a classic quadratic. And what kind of classic quadratic? A conventional classic quadratic. So I can simply say that x minus y all squared over x minus y. Now this might be confusing, but let me explain this to you. From this form here, you can simply say square the first term. So the first term is x squared. Now use the exponent to multiply through. We have plus 2 multiplied by x, also multiplied by minus y. Then square the last term, which is minus y, all squared. If you should do that, you will have x squared minus 2xy, then plus y squared. This is exactly same with what we have here. So it's all about your ability to move forward and take some step and see what it would have looked like when you had solved in the previous way. So it's all about thinking about forward and also backward. It can be confusing, but over time practice makes you see it clearly. So since it's exactly the same, it means this is correct. So right here, so we can simply have x minus y and then x plus y. So we are now employing difference of squares here now. So at first we did the conventional classic quadratic. Now we are doing difference of square. At this point, x minus y can cancel out x minus y, and finally we'll be left with x plus y, and we are done. So please, if this was confusing to you or didn't understand, you can go through this lesson again, go through this very one again until you are clear. So let's go for the next one. Here is the next one. The next one says a squared plus 2ab plus b squared equal to c squared. And it says that, okay, I'm going to put this one inside the box. Okay, c minus b is equal to 4. Assuming c is greater than 0, what is the value of a? So if you can look carefully, you can see that this is a conventional classic quadratic where you have a plus b all squared equal to c squared. Now if you can't see this clearly, I'm going to help you. Okay, so let's solve this. For this particular one, here you have a plus b all squared. We can actually say that squaring the first term, a squared, then plus 2 multiplied by ab, and then we square b. This becomes a squared plus 2ab. So okay, 2 times a times b, so there's a times here, then plus b squared is exactly what we have at this very point. So this is same as this. So let's go ahead and continue. So from this very point, we can say a squared plus b squared is equal to c squared. Now this is also related to the first rule, which is talking about difference of squares. But now I'm not talking about difference of squares, I'm talking about addition or sum of squares. So according to the rule of exponents, we can simply separate them. You understand? This is not difference of square. I want you to take note of the sign here, because I know you wanted us to say, okay, at this point we have a plus b all squared, then we'll have a minus b, and then a plus b. No, that's wrong. That's simply wrong, because the sign we have here is, so this is positive. You're not solving for difference of squares, you're solving for sum of squares. And I think that's why a whole lot of person might lose it in this kind of question. So we're talking about c minus b, right? So here we can have a squared is equal to c squared minus b squared, and we are asked to solve for a, right? So a, and then it says that c minus b is equal to 4. So we can simply say that a squared is equal to c minus b all squared, and what is c minus b is 4. So a squared is equal to, we can say 4 all squared, and a squared is equal to 16. So you can take the square root of both sides. If you take, let's continue from this point. If you take the square root of both sides, here you have a is equal to plus or minus 4. So it simply means that a is equal to minus 4, or a is equal to 4. And the rule says that c is greater than 0. Minus 4 is less than 0, so this does not work. Our right answer is 4. So in everything, a is equal to 4, and that's our final answer. I know this was quite confusing, but it's still under the rules classic quadratic, and that's why it's very, very necessary that you can easily identify classic quadratics anytime. And for the last question, it says x squared minus 10x plus 25 is all over 3x squared minus 75. So if you can look closely, you can see that the first This numerator can be simplified as x minus 5 all squared, and then here we can factor out 3 brackets x squared minus 25, because 3 times x squared is 3x squared and 3 times 25 is 75. Okay, so let me prove this to you before I continue solving. So for this one, where you have x minus 5 all squared, square the first term, s squared, then use 2 plus 2 multiplied by x, then also multiply by minus 5, then also square the last term, square it. So this becomes x squared minus 10x then plus 25, and that is exactly what we have at this numerator. So your ability to easily see the classic quadratic is going to make a whole lot of things easy for you, and that is what I want to let you know. So from this very point, you can continue solving and know that we can employ difference of squares here. So we have x minus 5 and then x plus 5, difference of squares, classic quadratic. Then here we have 3. Then same thing can happen here. We have x squared minus 5 squared, nothing changes. We've simplified our numerator, so we don't need to go ahead talking about that so much. But for the denominator, we'll have some work to do there. So we can have in brackets x minus 5 all squared. The same thing, nothing changes. You can also introduce another bracket to help you. Okay, let's say bring in more brackets. So let's say bring another bracket here, another one here to separate, but it's still the same thing. So let's continue from these very points. Now for the numerator, we'll have x minus 5 and x plus 5 all over 3 brackets x minus 5 x plus 5. So you see that we've actually simplified this because we apply difference of square to the numerator and also to the denominator. So right now we can cancel out x minus 5 cancel out x minus 5, then x plus 5 cancels x plus 5. So at the end of the day, we can have that 1 over 3. And we did this because we are able to identify our difference of square easily. So having said that, thank you so much for joining today, and do well to like, subscribe, comment, and also join our WhatsApp community for more questions and more interactive section. Thank you.